experiment and solve for K. So we're going to look at a problem here. Hydrogen plus iodine going to 2 hydrogen iodide. The rate law is rate equals K, hydrogen concentration to the M, iodine concentration to the N. And here's a sample, here's a set of data. Okay? Now, if we look at this set of data, notice that in, let's look at run 1 and 3. The concentration of iodine is the same. And in runs 2 and 4, the concentration of hydrogen is the same. So if I wanted to find M, I would choose experiments 1 and 3 because the concentration of iodine is the same. So I can say rate from experiment 1 over rate from experiment 3, and I've got some typos here. That should be 1. That should be 1. This should be 3. This should be 3. Okay, the rate from experiment 1 over the rate from experiment 3 has to equal K, hydrogen from experiment 1 to the M, iodine from experiment 1 to the N, divided by K, hydrogen from experiment 3 to the M, iodine from experiment 3 to the N. Now, let's plug things in. There's the rate from experiment 1, the rate from experiment 3, and that has to equal the concentration of hydrogen from experiment 1 to the M times concentration of iodine from experiment 1 to the N divided by concentration of hydrogen from experiment 3 to the M times the concentration of iodine from experiment 3 to the M. So notice 0.0011 to the N divides out, and the K's have divided out. So when I do the division, I get 0.204 equals 0.205 to the M. Within rounding, experimental error, those are the same numbers. So M is 1. I didn't have to use the log thing. Okay? If I now want to go after N, I'm going to use experiment 2 and experiment 4. That should be 4. That should be 4. So here, the K values, and I'll highlight these in yellow. K and K is the same. They're going to divide out. I've chosen this so that the hydrogen concentrations are the same. They're going to divide out. I'm not going to even write the numbers in. I just know that the concentrations are the same. I'm dividing them out. So I get rate from experiment 2 is 1.1 times 10 to the minus 22 divided by 1.9 times 10 to the minus 2 is equal to 0.0033 to the N over 0.0056 to the N. Okay? So I get 0.58 equals 0.59 to the N. By inspection, N equals 1. So now I have the rate law. Rate equals potassium. Rate equals K, hydrogen to the first power, iodine to the first power. Okay, so I get 1.99 times 10 to the minus 23 equals K, 0.0113 to the 1 times 0.0011 to the 1. So I get 1.9 times 10 to the minus 23 moles over liters times seconds equals K times 1.25 times 10 to the minus 5 moles squared over liters squared. So when I solve for K, I get 1.9 times 10 to the minus 18 liters over moles times seconds. Now you guys can work through example 14.2 on page 597. Okay? Now, I want you to note, okay, that the units on K are dependent on what the overall rate order is for this reaction. So the units on K is always equal to liters over moles, rate order minus 1 over our time unit. okay? So rate laws are nice, but they're static. And we need a reaction to help us describe concentration as a function of time. So that brings us to the integrated rate law, okay? So the integrated rate law is where we'll pick up in our next video.